NASA's known for its iconic Mission Control Center in Houston, Texas, where every NASA human mission into space has been controlled since 1965. Well, just like NASA uses a Mission Control Center to run its human operations in space, the human body has its very own Mission Control Center, the brain. But just imagine, if NASA's Mission Control Center had to work in environments it wasn't designed to operate in, things might not operate and function as planned. And that's what we'll be looking at, how the human body's mission control, the brain, operates in the unique environment of space. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Houston on 2 for velocity confirmation. Steps 4, 5, and 4, 6. We're moving on to step 5.
You want to go right now for that activity?
Copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
In this episode of Station Life, we're going to look at the brain in space and the associated studies conducted on board the International Space Station. We'll learn about the effects of microgravity on the brain and the psychological effects of living in relative isolation, far away from home, in a stressful and hazardous environment. We'll see how the European Space Agency is studying the effects of microgravity and neuroplasticity using parabolic flight. We'll talk about what it's like to acclimate to living in microgravity. We'll hear from scientists here at the Johnson Space Center that are studying sensory motor adaptability training and recovery of functional performance following long-duration spaceflight. Get ready, lots of information is heading your way.
One of the many challenges that we face on our mission to Mars is how our brain will adapt to the changes in gravity.
It could take up to 6 months to get there, but here's the problem.
The more time you spend in space, the longer it takes your brain to readapt to gravity.
So what does that mean? Landing on Mars after being weightless for 6 months, you have trouble walking straight.
Your vision is affected.
Poor eye-hand coordination.
Motion sickness.
Dizziness, vomiting.
Some people don't even want to move.
Landing is one of the most critical aspects of the journey.
So how will this impact our trip to Mars? First of all, landing on Mars will require good eye-hand coordination and perception.
So, say you have a safe touchdown.
But there's an emergency situation and you have to exit the vehicle.
If you can't function, it could be a pretty dangerous situation.
This is just one of the human challenges we'll face on a mission to Mars.
We don't have all the answers yet, but we do have the key.
The International Space Station.
Every day aboard, we're learning more and more about how our bodies adapt to weightless environments and gravitational transitions.
We're going to Mars.
It won't be easy, but because of the research that we're doing today on the ground and aboard the International Space Station, we'll be ready.
Today I've been looking actually at the brain and how the brain reacts to microgravity. In a sense, it's a very simple experiment because we do before we take off with the parabolic flight, we do an MRI measurement with a scanner in a hospital in Bordeaux, and then after the flight we do the same. And then we look at the image of the brain, and by subtracting both images before and after microgravity, by parabolic flight, we hope to see changes. These changes, it's called neuroplasticity. And neuroplasticity is something we all know somehow. I can give the example of a bicycle. If you are a kid and you ride a bicycle or you try, you fall over all the time because you can't do it. And then suddenly, like this, you can do it. And it's very tricky. Why? But somewhere in the brain there must be some connections, something which is happening. Well, actually, we want to do the same to find out how is the brain reacting to microgravity. Where does changes take place? In the brain, we all know it is a very, very complicated system with a lot of connections actually. And it's the connections which make differences between people, why people can make some logical reasoning and other people can do it less, or be creative or other type of habits. It has much to do with the connections in the brain. And these connections sometimes are also missing when in patients, for instance. So we want to look with this methodology of looking at the brain before and after such a huge impact as microgravity. We want to find out where does the changes take place which are related to dizziness, motion sickness, fluid shifts, things which really happen in astronauts and cosmonauts, but the same during onboard on this parabolic flight. By using the model of pre and post parabolic flight, we hope to find regions which are particularly busy and continuing to change all the time to adapt to microgravity, because it's known that people who fly the first day, well, many of them are ill if they don't take medication, but the second day or the third day, they are much better. So there must have been changes in the brain, real changes. That's what I want to look at. The methodology of MRI methods we use is a bit different than the normal ones. We look at diffusion in the neural tracts. And I can explain it simply by saying, suppose you have a helicopter and you stay with this helicopter like one day on top of a big city, Amsterdam or Brussels or London, but this camera of this helicopter has not the power to see the buildings. Only the people who are moving on their bike, walking or in the cars. After one day, you will have a map of this city. You will know the main roads, the smaller roads, the places where things are happening or are big streams of connectivity. That's what we do with this methodology of tractography by diffusion techniques in MRI.
So, when I first got to space on STS-118 on board Endeavour, it was my job to unstrap as soon as we got main engine cut off and float out of my seat, grab a video camera, and videotape the external tank falling away. So I was one of the very first people to get out of my seat, and all I remember is, I hope I don't screw this up. So I had no time to think about acclimating to microgravity. I had no time to think of, am I gonna get sick? Am I gonna be disoriented? I just knew I had to get that camera on the external tank. And I did that without any hitches, and after I launched on the Soyuz rocket and I got inside the space station, I just remember it being like this big swim tank. Your brain goes through this period where you think, that's not the way it is at home. But it was a matter of minutes before I just made sense out of it and flipped myself around. So it was not like that for everybody. But some of us get up there and it's just like you were made to float in space. Okay, so now coming back home, that's kind of a different story. When you come back into the tentacles of gravity, it pulls you down, it weighs you down, it makes you heavy, it makes you tired, it makes you feel like you are a big concrete cinder block, and it's all you can do to just lift your arm. I remember coming back from on my shuttle flight that I did feel a little disoriented, and walking by myself was a little bit of a challenge. But you get over it kind of quickly. But when I was on board the space station and I lived there for 6 months and I came back in a capsule and bam, landed on the ground, that was one of those cases where I felt like I weighed like an anvil, and I couldn't even lift my arm up to unhook myself from my seat, and I didn't know how I was going to get out of my seat. So coming back home was a bit of a rude awakening.
Hi, I'm Terry Virts, and I want to talk about floating in space. One of the first things that you need to realize when you get into space is that even though you feel like you're falling, you're not. And you don't have to flail like that. You can just sit still, you can let go, and you float. It's not a problem. It's something you really have to train your brain to think about. And it takes a little bit of time to get used to that sensation of falling, but realizing you're not falling. And you can pretend like you're on the moon. We have some bungees here. You can go down. And it's not quite gravity, but you can sort of be walking on the moon.
Well, welcome. Can you believe who we have with us today? I am so excited I can hardly get a sentence out, but we have with us today the one, the only, Mike Suffredini, the outgoing ISS program manager. Let's give it up. A big Station Life welcome to you. Thank you so much for being here.
Thank you so much for having me.
Oh, I am, obviously you can tell I'm really excited. I mean, just to put this in context, we have with us the big kahuna, the tribal leader, the decision-making dude of the ISS for the last decade. And there is just, I think, no better way to say bon voyage than to be here on Station Life. What do you think?
Absolutely, I think that's right. I walked through the front of Building 1 on my way in and out every day, and I see you talking about Station Life and all these things. I go, wow, I'd like to be a part of that sometime.
We are making dreams come true here on Station Life.
Right here.
Well, you know, when it comes to station, I think there's the name Suffredini and station are almost synonymous, because you have been with the station since the beginning when it was being assembled. And even before you became program manager, you have been a part of building and developing this space station. And when you stepped into the role as program manager, you had a vision. And I'm curious now, as you are retiring from NASA and leaving the station in some very capable hands, how you feel your vision from the beginning meets the vision here as you're leaving.
So, you know, when I came to the program, it's been about 20 years, so 10 as program manager, but 10 before that. You know, it was the idea of just building a station was a daunting task. The first several years of everyone's life was really about building it. Is it remotely possible to build it? We had all kinds of wild plans. Every element that flew to space station, we assumed in the design that it would fly twice, that it would go up to station once, we wouldn't be successful, it could fly home on the shuttle, we'd fix whatever the problem is and fly it again. Every single module was built that way. And of course, we'd never had to, which is a miracle in and of itself. So as we started to see the end in sight and said, my goodness gracious, we're actually gonna get this done, then we started thinking about the research more and more. Now, the research guys were always thinking about research. The rest of us, even as the research guy, the rest of us were focusing on just getting it built, but saying, okay, we have to do research sometime, and that's what the research guys really helped us keep the focus on. And a lot of the folks in management today have spent their time in research, which I think is good. But what research was back then was even different than what it is today.
So also with the research and the things you were mentioning, there's a lot of benefits of the International Space Station to humanity in all sorts of ways. And not just humanity in terms of right here on Earth, but also going beyond low Earth orbit. What are some of the things that you see the space station doing to help us get to beyond low Earth orbit, to Mars specifically?
So you know the biggest one, right? How do we keep people like you healthy? And that's a tough nut to crack. You know, we're starting to sort it out in low Earth orbit. I think crews are coming home now with, in a lot of cases, more bone mass than they left with. Even.
Yeah, that's right.
Amazing, right? So we're learning other things, the eyes issues associated with the eye that we're working on. So human health, of course, is the most important thing. And we say we need till 2026, but I would tell you it'll take beyond that. We'll be always learning about the human system.
So I know that you've got to leave the station in very capable hands with Kirk Shireman coming on board. You and Kirk have worked a long time together, and you've known each other for a long time. Yeah. I don't. Would you like to say anything more about that, or should I tell everybody that you guys go way back to high school and living on the same street and all of that? I mean,
we're from the same city, but we weren't pals back then. But I'm sure it has something to do with the water we were drinking or something that helped us get to where we are today.
Exactly.
Yeah, Kirk was, when I became program manager, it took me a little while to find a deputy, and Kirk was it. And Kirk has been with me for about 7.5, I don't remember the time, but it's like 7.5 years, and he went off to be deputy center director, and now he's back. So Kirk knows station cold. He's a wonderful individual. He's a great leader, so he'll do a great job. I feel like I've left it in capable hands. And of course, we have a number of individuals that operate different organizations. Flight Ops is one. There's a bunch of them. And I feel like the leadership team that's in place is very capable as well. So I feel good about that part of it, as much as I hate leaving this wonderful job that I've been doing.
Well, is there anything else that you can think of about the space station you want to share with the audience here?
You know, I will. You know, station, people have asked me, you know, what's your legacy? And to me, the station is not my legacy, but station is a legacy. And it is no kidding, no matter what anybody thinks today, it is no kidding. In the end, when we're going to Mars, we're going to look back and go, we were able to do it because we built that station, we successfully used that station, we kept it on orbit long enough to get everything we needed out of it so we could go do exploration, and we will look back on this and go, that was it. That's what we did to get us started in long-term exploration. So I think that's something that we ought to be proud of every day when we come to work, to say, this is it, this is the stepping stone, this is really the stepping stone.
All right, I can't add to that. That was awesome. And I just want to thank you so much, Mike, for being here
Thank you
today
for having me. It
and
was
being
awesome.
on StationLIFE.
I appreciate it.
This is a real treat. So thank you, and best wishes to you from everybody here at StationLIFE. And we are going to miss you so much.
Thank you so much.
Don't forget about us.
Oh, I won't forget about you. I'll be paying close attention.
Good, good.
All right.
All right, thank you.
Thank you, guys.
So not only are we studying the brain in space, but we're working on new countermeasures to train the brain for sensory motor adaptability right here on the ground. The Johnson Space Center's own Dr. Jacob Bloomberg and his team are hard at work creating new integrative countermeasures to mitigate post-flight disturbances in locomotor function. That's a fancy way to say that they're working on new training methods so astronauts can return home and adjust more quickly to the effects of gravity. Let's hear more about this training and its benefits from the man himself, Dr. Jacob Bloomberg.
Well, one of the countermeasures that we're now currently developing is called sensory motor adaptability training. And what we're trying to do in this countermeasure is basically train the brain to become more adaptable. The brain is a very adaptable machine. It allows you to adapt to so many things in ordinary life, but we're trying to tap in to that inherent adaptability to improve your ability to adapt to different gravitational transitions. Now, the way we're going to do that essentially is to train you on the ground to become a better adapter by exposing you to different sensory motor transformations. And what that really means is what we're going to do is put you on a treadmill that's placed on a 6 degree of freedom motion base with a virtual scene in front and have you walk in very unusual walking and visual environments. And what we know is that kind of training enhances your ability to adapt to new environments. So we can't simulate here on the ground the partial gravitational environments of the Moon or Mars, but we can simulate some of the sensory motor disturbances you will experience. So you can think of these more as surrogate challenges. And the idea is the more you train with these surrogate challenges, the better your brain will be when they encounter yet a new challenge. And this hinges on this whole idea of learning to learn. What this training does is enhances the brain to learn. And that's really what we're trying to do in our new countermeasure approach. Well, prior to this, we've been really discussing changes in behavior, the effects of spaceflight on behavior, for example, postural and gait instability. But the brain itself is a tissue just like bone and muscle, and it could potentially change as a result of exposure to long-duration spaceflight. We have some evidence with some of the animal work that there are structural changes that are associated with long-duration spaceflight. So we're now very interested to see if long-duration spaceflight is associated with changes in brain structure and function. So we now have a new study called neuromapping, and the PI in that study is Dr. Rachel Seidler from the University of Michigan. We're collaborating with her on this new study to investigate this issue. So what this study entails is looking at brain structure and function using modern neuromapping methodology to look at how the brain as a tissue changes and then compare that with potential changes in behavior and performance and look at the correlation between the two. So we're very excited about this new study, and we think it's going to reveal some very interesting data.
Welcome back, and thanks for watching this episode of Station Life, Brain in Space. Today we learned how we're using the International Space Station to better understand how our bodies adapt to weightless environments and gravitational transitions. This gained knowledge will help us once we get to Mars. We learned about sensory motor adaptability training and functional recovery, which also helps us better understand mobility challenges here on the Earth, such as defining more effective rehabilitation interventions in clinical populations. And we got to know the outgoing ISS program manager, Mike Suffredini. Talk about a solid show? This was it. Be sure to stay in touch and follow us on Facebook and Twitter for the latest research news. And don't forget to download our groovy app on your mobile device. Until next time, stay with us, off the Earth, for the Earth.